you've just heard from Tony, the KTN report actually paints a very bright future for NDT. But I just wonder if we ask a few questions about it, we can actually make it a better future than what it's actually predicting. Those of you who don't know me, I have had the privilege over the past few years of being able to use the NDT newspaper that you get every month as a PCN practitioner or a member of the British Institute of NDT to actually bombard you with my opinions on what I think about NDT. And so every month I have generated a blog, and if you actually read to the end of the blog and don't fall asleep, then you'll see that there's a disclaimer at the end where the responsibility for what's in the blog is totally down on me and has nothing to do with any organisation connected with me. But also the purpose of the blog is to encourage discussion. And it's something that I've been a total failure at. Apart from individual emails that people have sent to me, I've not actually managed to stimulate a discussion within the newspaper or in site or on the web. So whilst I'll still keep banging my head against that brick wall, I thought I'd change tack and actually come and give a presentation where I actually give you the opportunity to present your views, your ideas, which then I can take away and maybe do something with later on. So it's very important that you give me your input during this talk, and everybody here has a valid view. Just because I have the platform of NDT News doesn't mean my view is any more valid than anybody else's. And as I say, I'll always have next month to put forward what I want to say. But I want to say that we will use the KTN report as the basis for today's discussion. It is a very good report and it does paint a bright future for NDT. And personally, I've actually used it to encourage someone to consider NDT as a career, and that seems to be working. But as you might imagine, I have some views on the report and what's in it. And I'd like your views first before I put mine forward. So what I'm proposing to do is to look at some of the barriers which are identified in the report and ask, are we asking the right questions with these barriers? And then also look at some of the actions that the report recommends. Okay, so the barriers to growth that the report gives. The first one is, as Tony mentioned, that validation training and standards development are expensive and they actually slow the time to new technology to be brought to market. So the questions there are, do you agree? Do you think that's a valid comment? And also, why are these things expensive? Okay, but does it need to be expensive? The question is, are we doing it the right way round?
One of the times I got really burnt trying to deliver some technology was when the only vehicle we had was a real engine. And so we started to do this inspection, and we started to find things, and we thought they were the things we were supposed to be finding, and we had to take the engine apart, find out, and they weren't. Had I had a spare engine, which I could have worked on, I wouldn't have bothered the chief engineer of that engine, and he would still allow me back in his room. We had to wait for him to retire before we could approach him again in any sort of new technology. And I think a lot of plant owners are in a similar position. They really don't want a load of newfangled technology sat on their plant telling them stuff they've got to make decisions about. We need a place where we can do all that, and in an industrial sense, in a cooperative sense, and engage ourselves with the structural integrity community to make that happen. And then we come back to the plant owners and say, look, we've got a valid technique here, and the risk of it not being right is very low.
Okay, but I'd just like to point out that validation is a standard quality activity. If you look at any product or any service that's been designed, then it should be validated before it's put into service. So we're not the only industry sector that actually has to do validation. It's just we're a particular industry sector that makes a big issue out of validation. So maybe we're looking at it in slightly the wrong way. And if I just look at the time to market, I'll jump through to a slide which I had at the end in case I didn't get many people coming up, but I'll use it. Then if you look at the first smartphone, that was developed in 1994 by IBM and was the Simon smartphone. But then the iPhone, when smartphones really took off, wasn't developed to 2007. So you've got a 13-year gap there between the first smartphone being produced and it actually taking off and being a success. And here we're talking a fast-moving consumer good with a big market and probably a lot of money, more money than NDT had behind it. So when the report talks about the time-of-flight technique being a prime example of taking 20 years to get to mainstream, then maybe 20 years for NDT is not that long when you compare it to 13 years for the smartphone. There was a book produced by Temple and Charlesworth on time of flight, and although you probably can't see that, that's the contents page, and you can see that it's quite comprehensive. And if we look at the contents in more detail, it's got the theoretical basis of the time of flight there. It compares the signal amplitude with other techniques. It shows you how to design the equipment for simple geometries, looks at complex geometries, etc., and talks about applications. Now that was published, I should say, in 1989, which was only 4 years after the time of flight technique was launched properly in 1985. And it gives you all the information that you need to know about time of flight. So it even gives you diagrams there so you can work out the actual signal amplitudes for different angles of incidence as well. So why did it take us from 1989 to 2005 to actually get it in as a mainstream technique? Because all the information was there back in 1989. So if you bear that in mind, and we'll jump back to the previous slide. And we'll move on to the next two questions then for you, following on. So why do they slow the time to market? Why are we taking so long to get things operating? And how do other industry sectors cover? As I say, other industry sectors have to do validation. Pharmaceuticals, obviously, with drugs is another example. So can we learn any lessons from them? If you have any lessons that we can learn from them, then maybe we can take advantage of them. The next barrier to growth is that ND technologies can become buried in companies who have done the validation for specific tasks, but they don't publish the work, and so anybody else wanting to follow the same path has to reinvent the wheel. And so the questions I want to ask you on that is, do you agree with that? Do you think that we should be sharing everything that people come up with, or do people have a right to take advantage of what they develop?
Well, this one is a little bit close to my heart, because you mentioned time of flight and how long it took to get into the mainstream. And I started working with time of flight in 1983. And I worked for a company that was doing what you've commented here, trying to keep it in-house so they had a commercial advantage over other companies. And this is true what you say, that companies do keep certain technology back from the rest of us, and it doesn't get developed as quickly as if everybody had time of flight on day one. There might have been a lot more. It might have been a far greater success before it got squashed by phased array, etc. And that's my comment.
Having been involved in commercially trying to introduce a number of new technologies over the past 15 years or so, I'm thinking specifically of the air-coupled ultrasonics, which we were trying to introduce from a company called QMI in the US. The swept frequency work from a company called Southern Research, which Robert was also a bit involved in. And the problem I found with both of these is that although they did convey very useful advantages to somebody, nobody wanted to introduce them unless there were standards and so on that would permit their use. we could never work out a model to either fund that speculatively out of, some possible returns that we might get, or even if we had done that, I think there was really no model where, unlike the drug companies who, having spent many millions of dollars to introduce something, then have a worldwide protected market for some years. The problem with NDT, and I think we all know this, is that if you introduce a useful product, given that nobody has got those kind of legal resources, or at least the smaller companies haven't, if it actually works, somebody else will have a better Me Too in half an hour, and probably cheaper because they haven't paid all that development work. And I still don't think there's any good model to facilitate bringing anything in and protecting it in some useful way, or covering some of the cost, or anything that makes it feasible. At least I haven't found one.
But maybe someone else might have an idea that could come.
A couple of points to make. One is around validation being buried in companies, etc. We've heard a lot today about the oil and gas industry and how they're trying to tackle certification of personnel, but it's really validation of NDT techniques, because they've heard phased array will do this, and they say fine, okay. And what they were happening is a group of people would tip up at Total and they'd be given a whole load of trade tests to do, and 3 out of 10 of them would pass. And then the same people would go to BP and do the same sort of tests, and then go to Shell and do the same sort of tests. Total, Shell and BP weren't sharing those results, so it was enormously expensive and slowing the whole thing down. And what they said is, why don't we just get one authoritative body to do these tests on our behalf, and then we'll all accept that those individuals are, and those techniques are validated, and then we move on. Hence, they came to PCN. The other comment I meant about the expense and delay and all the rest of it, and again talking about time of flight diffraction, was that every time you talk to an organisation about, not every time, but a lot of the times you talk to an organisation about perhaps using time of flight, they'd say, oh yeah, some people came in here, told us it was the next fantastic thing, the Dutch have adopted it for everything, we tried it, it was absolutely rubbish. So sometimes, people grasp these technologies and ruin it for everyone else because they rush out into the marketplace and don't do it properly because it's not validated. And then that pushes the whole thing backwards, because then not only are you not being able to validate it, people just won't talk to you about it because they have this belief that it just doesn't work, because when they tried it, the first time round, it didn't work.
Okay, thank you.
Question back to you, really, or confirmation. Correct me if I'm wrong, but when you say time to become mainstream technique, I think you mean it's the length of time that's taken to develop a standard, and that standard is used and referred to.
I don't know whether that's
and
the case.
is the problem, is that the problem, that it just takes too long to develop the standards?
Well, it might be. I wasn't responsible for the text in the report, so I don't know whether that was the actual case of where the wording actually came from. But it is what the report said. But all I'm doing here is just trying to be the dirt in the oyster, really, and get you to sort of think about, why is it the case, and is there any way that we can get around this just by changing our perception, changing our way of looking at things, thinking about what's going on. Okay, so we're coming to the end, really. So the questions that you can have a think about is, do you agree? Is this a barrier? And do you want open source technologies? That is something that is being used a lot. Can we make money from that? How can we better protect the intellectual properties of the small companies, which has been identified? Can we change the way we do things so that can be protected for even if it's just a short period of time before it's then made available? And who will pay for that if we do open source? Who will pay for the developments? And then again, who and how will they profit from it? So all sort of things to consider. So I'll just briefly go on to the next slide, which was to look at enabling actions and look at the first one, and we'll just finish on this one. So I don't think anybody can argue with this one. We need to up the profile of NDT. And so has anybody got any new ideas on how we should be doing that?
Yeah, I think it actually mentions there about insurance companies. I worked for an insurance company for 13 years in the engineering department, and right next door to the claims department, and could never get to speak to them about, your claims could be massively reduced if we could convince your customers to do certain things that would stop them having incidents that were, destroying plant and hurting people. Just couldn't get them to listen. And I think that, if we can get the insurance industry to see the benefit of NDT rather than the cost, and stop just looking in the rear view mirror, because at the end of the day they just look at your claims record and adjust your premium accordingly. They could be more proactive, I think, but it's no easy task. As I say, I worked for one for 13 years. I couldn't get the claims department to speak to me, and I gave up.
Right.
But yes, that still remains a possibility.
I just think that we're very good at being in responsive mode, and so when people come to us because they've realised that an NDT technique might solve a problem for them, then we can respond. But what we should be doing is looking for the opportunities where we can go in and say, you've got a certain pain in your company because something that could be solved by NDT is costing you money. And I think that what we actually need to do is to better understand those organisations, the end users of what would be our NDT solution to those problems. So we have been trying to get more involved in structural integrity and sort of design and manufacturing to better understand that. And I think this problem is partly because we have been a bit insular and we haven't got out there and understood where the pain is, so that we can go in and speak their language in their terminology, and say we can perhaps provide a benefit that reduces that pain.
Again, we saw the demographic. How do we get more young people in? How do we raise the profile in the education system? Is our approach to the personnel, the personnel schemes that we have at the moment, is that the best one, or should we be looking at something different now for the 21st century? How could we improve it? And then the next step, going forward, there's a lot of people been sitting here. I know a lot of you are very clever. I know a lot of you have good ideas. So what I want you to do is think about what you would like the future to be, and then actually send your comments in. Put it onto Twitter. Those of you who've got Twitter would have noticed that we've been tweeting some of these questions that I've shown over the past 2 days. So please tweet your responses back. Facebook and LinkedIn, I have people who are connected to those, so they'll be able to get information off. You can email me or David on the address, which is on NDT News, or if you want to put it down in a letter, I'd really like to receive a letter from you as well. And also, in next month's NDT News, I'll sort of be following up on this discussion. So I'd like to say thank you to you all for coming up to the mic, because without you, it would have been a pretty boring presentation. And also, because of all the people that did come up to the mic, you've missed out on my story about my sink, so I'll save that for next time. Okay, thank you.